and quantifiers, that function symbols and relation symbols are graded, so they have an arity assigned to it, and that you have these bound and free occurrences of variables. Yeah, these are the three new things. But you could ask yourself, how are they related? Propositional logic and predicate logic, and basically, if all your predicate letters are nullary, yeah, and then basically you have the same. Yeah, you may have still quantifiers, but you have no variables which occur anywhere, so then you can forget about the quantifiers. So this is basic. Okay, now we have to deal with these variables somehow. Yeah, variables, as you know, are placeholders. Yeah, and at one point you want to replace the variables by something. Yeah, but what could the something be? Not much choice here. If you want to stay within the syntax, then the only thing that can probably be plugged in case of a variable is a term. Yeah, otherwise you would lose the well-formedness of your formulas. So you can only plug in terms. And well, how do you do this? Well, usually with a mapping. Yeah, you are mapping variables on terms. Okay. Now we will only look at such mappings which have a particular restriction, or which meet a particular condition. And the condition is that only a finite number of variables are not mapped to itself. Yeah? If you map variables on terms, then of course you can map x to x, because x is a variable and is a term at the same time. Okay? And so we will look only at mappings where only a finite number of variables is not mapped to itself. All the other mappings, yeah, are not of interest for us. And we will call these guys, which meet this particular condition, a substitution. Yeah? So a substitution is a mapping from the set of variables into the set of terms where only a finite number of variables is not mapped onto itself. Okay, now because of the condition, there's an easy way to represent substitutions. Yeah, you do not represent them as an infinite list, yeah, because we have infinitely many variables. You could think of an infinite list where you put the variable and the term to which the variable is assigned. Yeah, this would be very difficult to handle on a computer. But now, because of this condition, we can represent substitutions by a finite set of pairs of the form x is mapped to sigma of x, where sigma of x, of course, is not x itself. So we only store the pairs where a variable is not mapped onto itself. Yeah, this is a finite set. Yeah, and this is how we do it. So now, formally, we define by abuse of notation the domain of sigma, and I would say abuse, yeah, because we define it such that it is just a set x being a number, such that sigma x is different from x. Yeah, I mean, usually in mathematics you learn the domain is V, right? Domain. This is the domain of a function. So I call it a DOM, yeah? This distinguishes from the domain, but yeah. Usually in the literature they just call it domain by abuse of notation. So the domain of X is a set such that it contains all those variables which are not mapped onto itself, and by definition